Hey you guys, so this video is supposed to help you with Le Chatelier's principle pre-lab that I had assigned on Monday, and I meant to post the video earlier today and I just completely forgot. I forgot to take the video during class. So we're going to do that now. One thing that we talked about in class today was we went over the definition for chemical equilibrium, which is there. We talked about what that means. Hopefully you watched the Ed puzzle. We also talked about this principle, Le Chatelier's principle, right here. Okay, which says a principle stating that if a constraint is applied to a system that's already in equilibrium, the equilibrium will shift to counteract the effect of the constraint. So basically, if a system is at equilibrium or if it's in balance, but then you do something to change it or shift the balance, the system will try to adjust to reduce the change, okay, or counteract the change. So for example, what we were talking about today on the assignment for Monday, you probably got this activity, okay, and this is the one that we're working on this week in class. And so we did the first page today. We only did page 1. We talked about Le Chatelier's principle, and I had them read that paragraph, and we got into groups today. And we looked at this system right here, which basically you're taking this cobalt crystal that's got 6 water molecules attached, and we're mixing it with a chloride ion. And when you do that, it will shift to make cobalt tetrachloride and water molecules. And we said today that this system in equilibrium is pretty cool because you can actually see the shifts from right to left because they turn colors. Okay, when it shifts to the left, it will be pink. When it shifts to the right, it will be blue. Okay. So I had the kids look at this, and basically we came down to this part, and I said, okay, so what you guys are going to have to do is predict, do you think the system is going to turn pink or blue depending on what you add? And how do you know? How do you know if it's going to shift right or to the left? So one thing that we talked about was these are all the changes that we're going to do on Thursday. And then these are things, helpful hints that we need to know for Thursday. Hydrochloric acid, whenever it dissociates or breaks down in water, it produces these 2 types of ions. Okay, that's going to be important. We also want to recognize that water is going to be a product. Water is going to be a product in this reaction, so we're looking at this as the water, not this. So this is going to be our water as a product. Okay, also AgNO3, when that gets added, it reacts just with chloride. It pulls it out to make a precipitate. And then acetone or fingernail polish remover is used to remove water from glassware. Okay, so acetone can take out water. Okay, so having said that, I'm going to switch over here to the ladybugs. Okay, so having said that, what we talked about today was if you have this situation, and for instance, we want to know if you add HCl, what's going to happen to the system. Well, we already said up here in the hints that HCl will dissociate, or in other words, it breaks down into hydrogen chloride ions, okay? And that's important. So if you add hydrochloric acid into the system, I told the kids you need to look at it and see if you have either H or chloride, Cl ions, in the system already. And they identified that, yes, you do. You already have chloride. So if you add in hydrochloric acid, you're going to add in more chloride ions. So you add a whole lot more chloride to this side going into the system. So basically, you throw it out of balance. You add chloride, so that's too much. So what's the system going to do to relieve the stress or to reduce the change? Well, the system will begin to use up all of these chlorides, and it's going to start to make more product. And when it does, because it's going to try to use all this extra up, it shifts to the right and it's going to turn blue. And so that's what I told them to write, is that it would shift right, or you could also say it shifts forward That's the forward reaction. And it should turn blue. We'll see how it goes. Okay. Now on this one, adding H2O. Okay. If you add water to the system, if you're adding water to the system, I asked the kids, where would the water go? Where do you see it already? Okay. Well, water's already right there. Okay. So if you add water to the system, you're basically putting more water in to this side. You're putting way more water onto the product side. And because of that, it's like you overload this side. If you're adding water, it's overloading the product side. So you got too much water. So it's going to start to react with this ion right here. Okay. And it's going to start to make it shift back to the left because you got too much on this side. It causes imbalance. So it's going to start to react with that. And it's going to shift back to the left. And it should turn pink. And so that's what we're going to write. It should shift left, or in other words, the reverse reaction. Oops. And it should turn pink. All right. Now, if you add silver nitrate, it already said silver nitrate will react with chloride. Okay. So you need to go up there and find where the chloride is. Okay. And remember, we said it's right here on this side. If silver nitrate goes in there and reacts with the chloride, it's basically going to pull that chloride out. So it's going to pull it out of the system, and it's going to begin to react with that silver nitrate. So if you're pulling it out, if you're taking this part out of the system, basically the system looks and says, oh no, we're missing chloride because it's being taken out by the AgNO3. If you're losing it, what's the system going to do? It's going to try to replace it, okay? And the only way to do that is to produce more of it. So it's going to, again, shift to the left because you're running out, so you want to make more of it. So it's going to shift and start to make more of those chloride ions. So shift left, which is the reverse reaction, and pink. That's what it should do. Okay, what about if you add acetone? How's that going to affect it? Well, what do you know about acetone? Acetone can be used as a water remover. It can take water out of glassware in a lab, like you have a really skinny tube that you need to get water out of. You put acetone in there and it'll basically cause it to evaporate very quickly. Okay, so if you know that acetone has water removing properties, you got to ask yourself, where do I see water in this equation? And remember, we consider water to be a product here. Okay, water is a product here. So if you've got water as a product, we don't count this because it's attached to a chemical. So this is part of a chemical. So technically that's not really water. It's part of a hydrated chemical. Okay, so here's water. But if acetone is added, it's going to basically take this water out. So if you're removing water out of the system, if you're taking it off of this side, what's the system going to do? It's going to try to make more. It's going to begin to shift to make more. It wants to shift to the right to produce more water. So here, we're just going to say it's going to shift to the right. And we see that's the forward reaction. And that forward reaction, you would expect it to turn blue, hopefully. These last two were the two that tripped most kids up today. Okay, hot water bath and ice water bath. How do we know what's going to happen if you put it in hot water versus cold water? Well, another little key piece of information here is they tell us that the reaction is endothermic, not ectothermic, endothermic. If the system is endothermic, that means basically that energy has to go into the system in order to make it work, okay? So if it's endothermic energy, you could treat it like a product, or not a product, a reactant. Energy has to go into the system in order to make it work. So energy gets absorbed as a starter, okay? So at equilibrium, this is what would happen. So what happens though if you take this system here and you put it like in a hot water bath? If you put some fire to it, okay, this is supposed to be fire, right? Okay, so I'm going to put fire. I'm going to add energy into the system. So I'm going to put more energy into the system. I'm going to put more energy onto the side. So you have extra energy on this side. So I've got too much. So what's the system going to do? Because I have too much energy on that side. What will it do? If you have too much, if you have more energy and you treat it like a reactant, I have too many reactants now, it's going to shift to get rid of it. It's going to shift to use some of that energy. So it's going to shift to the right. So shift right to make the forward reaction go. And we know that that's blue. Okay. All right. And then finally, ice water bath. I know you guys are thinking, oh, it's just the opposite, right? Yes, it is. But why? Again, if the reaction is endothermic at equilibrium, okay, at equilibrium, it's endothermic, which means the energy is treated like a reactant. Energy has to be present in order to get this thing going. All right. Well, if you put it in an ice water bath, so let's say that we give it some ice cubes. Okay, those are ice cubes. Give some ice cubes. If this is energy, this is high energy. These are low energy. So that's low energy. This is high. Okay, how does energy travel? Energy always travels from areas of high energy to low energy. So it would travel from high to low. So energy here is going to leave the system. So if you're losing energy on the side, if energy is going out of the system because it's in an ice water bath, how does the system fix the change? What's it going to need to do? It wants to replace it. It's got to replace the energy. So it's going to shift back to the left. Okay, so it's going to shift to the left. Should be pink, hopefully. And that's the reverse reaction. I forgot to put that. That's the reverse reaction. Okay. That's basically in a nutshell what we talked about today. We got into groups and discussed it like in a big group discussion, but you get the idea, hopefully. All right. Hope this helps.